All right, so now we're into the derivatives of the quotients. We've seen the derivative of products, now the quotients. So the derivative of a quotient of two functions is not the quotient of the derivatives of the two functions. Let's just start with that. The derivative of the quotient of two functions is the denominator times the derivative of the numerator minus the numerator times the derivative of the denominator, all divided by the denominator squared. Now, this quotient rule is expressed here in Theorem 2. And again, they made it simple. This isn't usually how it's labeled, but they put t for top, b for bottom. And so if we have the function y equals f of x is the top over the bottom function, and we can find the derivative of both the top and the bottom, then our derivative of f of x is f prime of x equals b of x times t prime of x minus t of x times b prime of x all over b of x squared. And again, simplified notation, y prime is equal to b t prime minus t b prime over b squared. Or if we're using the dy dx's, then this is just going to be the dt dx, db dx, and then just b squared on the bottom with the other things appropriately. So the key here is the last one with products, we had a plus. Here we have a minus. So kind of the same thing otherwise. And we also put that squared down here in the bottom. All right, so what we want to do is we want to find the derivative of these three functions. All right, so maybe, so we don't forget, let's write up here f prime, oops, let's erase that, make it a little nicer, maybe. F prime of x is equal to, well, remember, it was the bottom times the derivative of the top minus the top times the derivative of the bottom all over the bottom squared. So again, most simplified form here, so we don't have to write everything out. So let's do A. All right, so f prime of x is going to be equal to what? Well, now we're going to take the bottom, which is the x squared plus 3 times the derivative of the top. Well, that's just going to be 2. Now remember, minus, now we're going to take the top, which was 2x, times the derivative of the bottom. Well, that's going to be 2x, all over the bottom squared, x squared plus 3. All right, so only thing I can see is we can simplify. So that's going to be what? A 2x squared plus 6 minus, and that's going to be a 4x squared all over, oops, somehow the square didn't come out here, x squared plus 3 squared, okay? All right, this can be simplified then into what? Minus 2x squared plus 6 all over x squared plus 3 squared. All right. Now, this can't be simplified anymore, so I would say that would be my final derivative that I would write down here. Okay, so that's the derivative of this one. All right, so let's do B now. Let's do it over here since that's kind of how it's shown. B. So now we have this function we're working with. So we want to find y prime. Maybe we should move this up so we can have enough room to get all this in here because it probably looks like it's going to be long. So y prime, and this is b, is equal to what? Well, the bottom is going to be t squared minus 4 times the derivative of the top. So that's going to be what? A 3t squared minus 3. And then we have minus the top, which is t cubed minus 3t, times the derivative of the bottom. So it's going to be what? A 2t. Oop, not 2t squared, just 2t. And then all over the bottom squared. Okay. Now, can we simplify that? Yeah, it looks like we can multiply all that out. Now, depending on the book, sometimes they might say, okay, we'll go ahead and stop here. Sometimes they might say simplify all the way. So if we simplify all the way, so that's going to be a 3t to the fourth. Then outside's going to be a minus 3t squared. Inside's going to be a minus 12t squared. Then it's going to be a plus 12. Then we have a minus 2t times that, so it's going to be a minus 2t 4. Is that a cubed? Yeah, it's a cube, so that's a fourth. Can't read my own writing here. All right, so that's a cube, so that's going to be a 2t to the fourth. And then that's a minus times a minus, so that's going to be a plus, and that's going to be a 6t squared. And again, we're not going to simplify the denominator. We're just going to say that's a t squared minus 4 over, and that's all squared. All right, so now we have a 3 minus 2, so that gives us t to the fourth. We have a minus 3 minus 12, and then plus 6. So it's going to be minus 6, but that's going to be a minus 9t squared. And then we just have plus 12 all over t squared minus 4, the quantity squared. Okay. And so that then looks like my final derivative of that quotient. All right, so the last one now says find it in two ways. Okay, well, so they're being complicated here for us. All right, so first way I guess we could do is we could use what we've just been doing. So this is going to be d dx is equal to what? Well, we're going to take our bottom, which is x cubed, times the derivative of the top, so that's going to be what? 3x squared, minus our top, 2 plus x cubed, okay? And then times the derivative of the bottom, which is going to be a 3x squared, all over, and we have an x cubed squared. All right, so that's going to give us what? That's going to be a 3x to the fifth. And then that's going to be a minus 6x squared. And then that's going to be a minus 3x to the fifth. And then that's all over x to the sixth. Okay. Now, what do we do? Well, now we simplify that. Well, guess what? If we change colors, we can cancel stuff. Well, that's 3x to the fifth minus 3x to the fifth. Those are gone. Two of those cancel two of those. So we have 4 here. And so all that's left, it looks like, is a minus 6 over x to the fourth. And so that then is the derivative doing the quotient rule. Now, what's the other kind of rule we could do? Well, we could go ahead and say, okay, well, let's take this original and say, okay, we're going to take 2 divided by x cubed and then x cubed divided by x cubed. And so that's going to be 2 over x cubed plus x cubed over x cubed. And that's going to be basically a 2x to the negative 3 and then what? Plus 1, because those cancel and we just have plus 1. And so really all we're doing is we're finding the derivative of this. And so dx is going to be what? Well, it's going to be a minus 6 x to the minus 4, which is a minus 6 over x to the 4th. Boy, that was sure a lot easier than that way, but this is the way they said, why they said to do it two ways. So you could see it's really quick this way, and it sometimes takes a lot longer this way. But using the quotient rule really, again, is one of those things that's like the product rule. You have to use it sometimes, and so we might as well get used to using it all the time. All right, so let's stop there and we'll come back for more.